You're watching Mrs. Perez, Module 3, Topic 1, Lesson 3 video. In today's lesson, it's titled, What's in a Name? Rational Number System. So we're going to talk about a lot of different names of our numbers that you may or may not know. Starting with our learning goals, we're on page 469. First learning goal. Our first learning goal is classify numbers according to their number systems. The second learning goal, apply and extend an understanding of whole numbers and integers to the system of rational numbers. For 3, understand ordering of rational numbers. Key terms. There are 4 key terms here: integers, ellipsis, rational numbers, and density property. Okay, we are skipping to page 472. I apologize for marking through this because we do have our key terms here. If you do have your key term journal, this is a good time to make sure you have that out and ready to go to fill in your blanks. Throughout this topic, you have been learning about a set of integers. Integers are a set of whole numbers with their opposites. So positive 1, negative 1, 2, negative 2, 3, 3 and negative 3. Those are positive numbers and their opposites. Whole numbers are always going to be positive. So whole numbers and their opposites, and the opposite of positive is negative, is what we learned in another lesson. Okay? So this is your example of integers. Okay, moving on to our next key term. You have also worked with rational numbers throughout this year. Rational numbers are a set of numbers that can be written as A or B, so basically a fraction, where A and B are integers and B is not equal to 0. Rational numbers, a lot of times I like to call rational numbers your whole numbers, fractions, and decimals. Whole numbers, fractions, and decimals is what I like to call rational numbers. And then you'll see your other key term here, ellipsis. Notice the 3 periods before and after. So this right here, before and after, is your example of an ellipsis. These 3 periods are called ellipses, and they are used to represent infinity in a number set. It means that, yes, those numbers aren't there, but they do keep going there. That is what those 3 numbers are trying to tell you. Okay, we're going to skip to page 473. There are many ways you can classify numbers. As you saw in the previous activity, many of the classifications are subsets or other classifications. The diagram shown the different sets of numbers you have encountered in your mathematical experience. Natural numbers. Natural numbers are all your numbers that you count with, 1, 2, 3, 4, and so on. So those are your natural numbers, 3, and so on. Okay, whole numbers are all of these, but it also includes 0. Notice that natural numbers, counting numbers, you don't usually count by 0, because if you just count by 0, it's 0. So natural number does not include 0, but wholes includes all of these natural numbers plus 0. Okay, integers are going to be all of these with 0 and all of your negative numbers. So all of those are included, as well as all of your negative numbers for integers. Then you have rational numbers. Well, rational numbers include all your counting, all your zeros, all your negatives, but it also includes fractions and decimals. It's going to include all of that plus fractions and decimals. However, fractions and decimals are not integers. and they are not whole numbers, and they are not natural. You can't go back. You can go forward, but you can't go back when it comes to this. So let's fill in some of these tables. We're going to go ahead and pin the number on the bullseye. We're going to skip that. Never mind. Sorry. For each value, check all of the number sets to which it belongs. So 3, natural number. Is that a counting number? Well, yes, that's a counting number. 3 is also a positive number, so that can be included. What you'll notice is that if it's a natural number, it will also be a whole, integer, and rational. So if it's natural, it's got to be the rest of these. So that would be yes for the rest. Okay, 3.22. Well, decimals can't be here, or here. None of these include decimals. The only one that includes decimals is a rational number. So that would be a rational. 0. Well, remember, natural does not include 0. So it can't be a natural, but whole number includes 0, so it can be those. Because remember, if it's here, it can also be integer and rational. Okay, negative 4.5. That's a decimal. Since that's a decimal, it can't be in any one of these in the bullseye. It can only be rational because it's a decimal. That's a fraction, and it's not an improper fraction, which would create a whole. So that one would have to be rational only because fractions are only in rational. 54. 54 is a natural counting number. It's a whole, it's an integer, and it's a rational. It is all of these. Remember, if it's a natural, it has to be the rest. Okay, negative 5. That's not a natural number. That's not a natural number including 0, but it is a negative number, so that could be an integer. And if it's an integer, it also has to be a rational number. Okay. Ooh, 22/3. Could that create a whole number? Well, let's see. 3 can only go into 23 the most 7 times. Oh, I would get 7 2/3 if I did that. So that has to be only a rational number. That's a decimal. And remember, decimals can only be rational numbers. This is a negative, but there's no decimal there or a fraction. And negatives could be integers and rational. So that would be our answer there. So we filled in our blanks. Notice here, all of these were considered rational numbers. Every single one of those were rational numbers. Okay. We're going to go ahead and describe what we can think of whenever we're looking at natural, wholes, integers, and rational numbers. Okay. Here's our example and our description. Natural numbers are 1, 2, 3, and so on. Those are your counting numbers. Whole numbers are going to be all of these plus 0. So I'm going to put 0, 1, 2, 3, and so on. Okay. Going on to integers. Integers are whole, natural, and your opposites. Okay. Rational numbers. Rational numbers, remember, can be fractions, they can be decimals, and they can also be all of these over here. So for our description, we're going to put fractions, decimals, integers, which if it's a whole, it will also be a natural number. So fractions, decimals, integers, and wholes is a good description for rational numbers, okay? All right, last thing that we're going to do, we're going to look at this bullseye, and on page 476, we're going to try to use that bullseye to answer these true and false questions. Okay, number 1, all whole numbers are rational. All whole are rational. Since it's inside of the bullseye and rational is on the outside, that means that has to be true. Okay, all rational are whole numbers. Well, since rational is outside of whole, that has to be false, because not all whole number or all rational numbers are whole numbers. So that would be false. Okay. All rational numbers are integers. Again, not all rational numbers can be integers. Okay, we can't put a fraction or a decimal in integers. All integers are rationals. Since integers are on the inside and rationals on the outside, that would be true. You can't, all integers will be rational because every number is a rational on what we've learned on the bullseye so far. All whole numbers are integers. Again, whole is on the inside and integers are on the outside of that, so that would be true. All of our whole numbers are going to be integers. All integers are whole numbers. Not all of our integers can be a whole number, because remember, negative numbers is not a positive whole number. So that would be false. Okay, we have finished our lesson. Thank you for watching. Rewatch this as many times as you need to so you can get your notes, and I hope you have a great day. Thanks.